Hello and welcome to my presentation on my capstone project course on student-centered chemistry, the personalized approach to learning general chemistry. So looking at the general standards and the classification for the curriculum, you can see that I listed out all the units. This course is a 14-unit lesson or curriculum, and with the NGSS standards now applied, you can see that most units have anywhere from 1 to 3 standards applicable. Based off from that, you can now see that a lot of them are repeated. There are some that are not, but there are some that are. And we're going to talk about the NGSS standards and how they relate to the overall course development. So looking at some of the standards here, you can see such as high school PS1-1 is the usage periodic table as a model to predict the relative properties of an element based on their patterns of electrons in the outermost energy level of atoms. So when you're looking at those, you can see the description of the electrons and where they are located. So to most people, they might not see the interrelationship between standards. However, being a chemist myself, and I've taught in this course many times, there are a lot of overlying principles between each of the standards. So as we look at HSPS1-1, for example, you can look right next door to that to HSPS 1-4, and it says develop a model to illustrate that the release or absorption of energy from a chemical reaction system depends upon the change in the total bond energy. So when we talk about bond energy, that actually talks about electrons. Okay, so when you're using bonds and making bonds, you have to use the periodic table. Since you're using periodic table, you're talking about valence electrons, which are the outermost, so based off the patterns of electrons in the outermost energy levels and how they relate together. So on the surface, they don't look interconnected. However, based off of the understanding and going through the course, you're going to see a lot of connection between the standards and this idea and one of the principles of the underlying piece of the course. Again, kind of looking at that, refine the design of a chemical system by specifying a change in conditions that would produce increased amounts of products at equilibrium. It goes back to bonding, which goes back to electrons. So again, kind of touching on this concept that I'm going to talk about in a minute. And again, some more standards. Again, looking at those, communicate scientific and technical information about why the particular level structure is important in the functioning of design materials. That's HSPS 2-6. So again, with chemical reactions, why would they take place? Well, it's based off from electrons. Based off from those electrons goes back to that HSPS 1-1. So again, a huge combination between standards as they go through the course. So really what this goes back to is one of my big course approaches, and I kind of broke this down into 3 big, huge things, especially in my capstone. The first being personalized learning, which some of you may or may not be familiar with. Personalized learning is kind of a concept of student-centered learning, but it's where the student really takes ownership of the course and what they are learning and their way of showing how and what they're learning. Second is an interleaving and inductive thinking. So this goes back to the brain and how the brain operates and deals with different types of material. And then kind of to foster those first 2 ideas is the technology integration for assessments and assignments. So looking at personalized learning, I think Childress and Benson said it best. Personalized learning can meet all students where they are, motivate them based off their interests and academic levels, and accelerate their learning and prepare them to become true lifelong learners. I love this quote because it really kind of goes back to the fundamentals of why I developed the course and the way I developed it. Is it really just lets the student learn at their pace, the way they want to learn, and then lets them be successful. Kind of going with that personalized learning comes up this idea of differentiated instruction. Differentiated instruction was touched on many times in my capstone, but bringing different modes of learning and letting the students select which modes they want to learn by, or allowing them to learn by multiple modes so that they're not just stuck in one type of mode of learning. And it kind of goes back to the last part of different modes of learning. These things are huge, being kinesthetic versus auditory versus being maybe visual or even with written language, is that by the more modes you use, the more that this is becoming a one-on-one course for the student and them being able to select or by learning in multiple different modes. So really, the different modes actually plays into this other objective of mine in this course of interleaving and inductive thinking. So inductive reasoning is related to one's ability, to one's intelligence, and they're really and by enhancing their intelligence, they're enabled to enhance their inductive reasoning. So inductive reasoning is the ability to take multiple bits of information and build them up and to create a summary, which kind of goes to the second piece here. Increasing one's inductive reasoning allows one to the ability to make predictions and new hypotheses, which helps with general understanding, gives one the skill to become a lifelong learner. My goal with this course isn't just to teach students chemistry, but it's also to teach them the skills necessary to be successful for their life. I always equate this course with high school, but not so much being a high school course, but a preparatory class for that of college. Taking a content which is typically seen as difficult or challenging, or sometimes for some students impossible, and making the impossible possible by breaking this down in such a term and such a way that it is now accessible for all students to be successful. Kind of goes to my last part there. Interleaving allows students to perform inductive thinking more effectively than that of block teaching. The rationale that more time to compare and contrast various groups allows the individual to make connections and ultimately form better conclusions and connections to information. Um, really kind of draws this whole idea together between the personalized concept and the interleaving and the inductive thinking. So earlier I touched on the different standards and seeing how the standards really blended together, and this goes back to that interleaving practice, that we start with this basic foundation, and as we progress we become more and more complex. So what we're doing is we're giving the fundamental pieces for students to be able to build their predictions and their hypotheses of why the world behaves the way it does at a chemical standpoint. And as they move through the course, they're starting to see more interconnections of electrons all the way up to acids and bases, all the way up to organic functions. And that's really where this underlining principle takes place, which really goes into my last part of technology integration for assessments and assignments. Hoffman and Ramirez said it the best when they said the students from a survey, this was a survey that they did, believe that the teachers use technology within the classroom is vital for the overall performance in life, and they indicate they thrive when teachers use technology in group work. I really like this because one of the fundamental pieces for this course is that you're using technology over and over again. And what it does now, especially in a data-driven age and technology-driven age, it allows students to use something that they're comfortable with to understand or discover something that they're uncomfortable with. The other part is, in that same report, they stated that during technology-based activities, students were engaged and motivated to complete the assignment. So again, using that thing that they're comfortable with to achieve something that they might be uncomfortable with allows them to complete and move on throughout the course. And in another study, their observations were shown that the course is properly created. It can be engaging as any. When created with proper time, use of interleaving of information, and shown the study had a greater learning experience and achieved. So personally, I think that the foundation and the outline of any course is crucial to the success of the course. And that's why I spent so much time and effort into designing this course in such a methodical way, so that when students complete this, they see that the first day and the last day are combined. And that, again, using that interleaving and inductive thinking, along with technology integration and along with that personalized student-centered learning, it allows the students to really take hold of their learning. So really what I did with this course is I put it all online on this website, and they have all the assignments, the pacing guides, everything that they need to be successful. And really and truly, a student can go through this whole entire course from start to finish and really don't need much integration from an instructor other than the instructions that I have given them. There are aspects in here which are more fundamental for a classroom setting, but again, I did this in a way that anybody could pick up the course and go from start to finish and have a general understanding of chemistry. References, I use a lot of references in my capstone. A couple that I touched on in this presentation alone, that I just wanted to make mention to, that I did throughout the 20 references as what we were required to complete. But again, just touching on those indications of the connection between personalized learning and that of inductive thinking and interleaving and then that use of integration of technology. I think that this curriculum is very sound in development and foundations, in that where students can complete the course and be successful for a general understanding of chemistry.